Mr. Beeland here with your math lesson for today. We're continuing on with factoring trinomials. This time we're looking at the special cases, okay? Perfect squares and difference of squares. Okay, so I've got 3 examples here. I've got a 4th one I'll have to show you afterwards. We'll start with these 3. Okay, this one on the far side here, x squared plus 18x plus 81. So the trick with these problems is identifying that they are perfect square problems. And the way that we do that is by seeing that it is in the form of x squared plus 2ax plus a squared. Okay, so again, we're seeing that 2 times a number will give us 18, and that number squared will give us 81. Okay, one of the quickest ways to find that indicator is just to see that this is a perfect square. As soon as we see that that is a perfect square, then we can ask, does 2 times that number make 18? Okay, you can also go through these just like a normal FOIL problem, or sorry, a normal factoring problem, and that'll work out fine as well. But if you can see that it is a perfect square, you might be able to get through it a little bit quicker. So again, it is of the form 2ax plus a squared, right? So again, we're going to want those brackets. We're going to want to put those x's in there. It's all positive, right? And then what number multiplies into 81 and then adds up into 18, or 2 times that number is 18? It is 9, right? 9 squared is 81. 9 plus 9, or 9 times 2, is 18. Now from here, this one we aren't finished yet. We do have to put it together as x plus 9 squared. So again, if you can identify that it is a perfect square trinomial, you can end up putting it straight down into this format. Okay, this one here, it's a lot easier to identify that it's a special case. And that's because it is missing the middle term. And the only special case that we were looking at that was missing the middle term was the difference of squares, right? So difference of squares was x plus a times x minus a. And if you go through the FOIL or the expansion of this, you will see that the middle term cancels out. You'll have ax minus ax, and that gets rid of it. So with this one, all we need to do is take the square root of this number here to figure out what the other piece is. Again, we'll start off by putting our brackets down. And we know, because immediately that it's a difference of squares problem, that it is x plus and x minus. We just need to find out what the square root of 10 is, or square root of 100 is, and it is 10. So it's x plus 10 and x minus 10. Now with these problems, difference of squares problems, I may actually give you a coefficient in front of the x. Okay, we haven't worked with that before, but it will come up in the difference of squares problems. The trick with these ones is, again, that you're just going to take the square root of the coefficient and put that in front of your x in your x plus and x minus piece. So again, I'm going to put my brackets up. I'm going to put my x plus and my x minus, and then I just need to see what the square root of 9 is. Square root of 9 is 3. So we put 3 and 3 there. And then the next thing we have to do is just take the square root of 64, which is 8. So we have 3x plus 8, 3x minus 8. Again, you could go through the whole process just like before. You would say, okay, well, what 2 numbers multiply into 64 but add up to 0? And in order for something to add up to 0, it would have to be the positive and the negative version of it to cancel out, right? 8 minus 8 would cancel out. So this is a little bit of a quicker way to go about it. Now again, with the difference of squares problem, there is one more little trick or special case that may go with this. And that is if you cannot find a perfect square to start, right? You see 9 is a perfect square, 64 is a perfect square. It's an easy problem, right? But what if you don't have a perfect square? What if you have something like 8x squared minus 50? Now we can see just from looking at this, it's missing that middle term, so it's got to be a difference of squares problem. But the square root of 8 is like 2 point something something something, and the square root of 50 is just a bit bigger than 7. So it doesn't quite work out. So you may have to factor out a multiple first. So you may have to look at those two terms and say, okay, well, what can I pull out? And we see here we have an 8 and we have 50. So what is the greatest common factor of 8 and 50? It's 2, right? You can take a 2 out of here, you can take a 2 out of here. What happens when you do that? Well, you put the 2 on the outside, brackets, and what would the remaining coefficient be if you take 2 out of the 8 is 4, right? 8 divided by 2 is 4, x squared. 50 divided by 2 is 25. Now if we look at this, 4 is a perfect square, 25 is a perfect square, so now we can break that into the difference of squares problem. The 2 stays out front, and you're going to want to put your brackets, and then 4, the square root of 4 is 2, so 2x and 2x, and then it's plus and minus, and the square root of 25 is 5, so the 5's going there. Okay, so you have perfect square problems. The trick with them is just identifying that they are perfect square problems. And you have a couple different types of difference of squares problems. Ones where they're very straightforward, there's no coefficient, it's easy to go through. One where you do have a coefficient in front of that x, and then one where it may not be a perfect square. But the nice thing about them is that they are easy to